Okay, folks, last 3 or 4 videos we made, we did some testing to try to drive the TSO or two-stage oscillator, but using electromagnets and permanent magnets. The experiments that we did showed positive signs of ability, so we've gone ahead and make the rig to put on the big two-stage oscillator I have outside here. And what we're doing is we're taking 3 layers of 1-inch thick aluminum. The hole that we're cutting in them for the electromagnet that we made, we're cutting a little bit larger than the electromagnet, and we've put plastic PVC pipe around it to put it in here. What we're going to do is the outside, 2 outside pieces, not the inner, but the 2 outside pieces, we're going to drill a hole and tap it for a set screw. That way we can slide the electromagnet in and out and adjust it. For the permanent magnet, we have already JB welded on the two-stage oscillator outside. It is a 1-inch by 1-inch by 4-inch N45 magnet that pulls 205 pounds. The poles are on the 1-inch by 4-inch sides. So we've placed it up there. Now it's going to be a long magnet, about 8, like so. This one's going to be a round magnet, and we're hoping that it'll curve around it a lot easier as it swings. The electromagnet's going to be on the moving part. The electromagnet being 3 1/4, 2 3/4 to 3 1/4 inches in diameter. If we tried to swing the magnet around it, it would take too big of an arc, and we'd have to hold the magnet too far away from the electromagnet. So what we're going to do is let the electromagnet swing around the 1-inch by 1-inch by 4-inch permanent magnet. Now this is the plug we've cut out. This, the round electromagnet that Jermaine made himself, fits in here with the PVC pipe. Now the reason we did that is so that if for some reason the electromagnet is not strong enough to kick, we can take it out, take the plastic pipe off, and run more coil around the electromagnet. I mean, it's just trying to think about the future. Now, you can see this, we've already drilled a hole to mount this. We've drilled a hole to this piece to mount it to here, and the next piece will mount to that. Okay, and then, of course, the one on the back and the one in front will have set screws drilled and tapped on both sides. That way, when we get the magnet adjusted properly, we can set it and lock it in place. What we're going to do just for a few minutes here, we're going to cut, and I'm going to show you a video I made once before that said that I do not use cutting oil on any kind of a drill press or cutting machine that rotates. If it's metal, I use ice water. If it's some kind of wood, like composite wood, MDF, your OSB board, plywood, anything that has glue, the heat will melt the glue and gum up the teeth on your saw. So on wood, composite wood, I use cold air. Okay, well, we're doing aluminum, we're cutting with a cup saw, and I'm using water, ice water, okay, in a spray bottle. So Jermaine's going to step over here and turn the drill press on. We're going to cut it. Okay. As you spray the water, somebody operates the drill press, and you spray the water, you want to feel the aluminum, make sure it's not too warm. This is not too warm to practice cold and stuff. Oil is a lubricant. Saws and drill bits cut with friction. So anytime you use a cutting oil, you're heating your cut, all the oil is pulling your blade cool so it doesn't get hot and wood. So using cold water is cheaper and better. Your blade drill bits will cut 5 times as much before they wear out if you use cold water. Okay? So just cut that here while the bullets away from the water. As long as it stays cool,